In the previous lesson, we saw that basically if the weight of water displaced by the ship below the keel is equal to the ship's weight, whatever is above the keel will remain afloat above the waterline. We are going to look at this in more detail in this lesson. First, let's review weight. In daily life, when people talk about weight, like 50 kilograms or 10 tons, they actually are talking about mass, not weight. In physics, weight is a measure of how much gravitational force pulls on an object. Because the Earth pulls everything towards its center, weight has the direction of the Earth's gravitational force, which is downward. The weight of an object, denoted by W, equals the gravitational force acting on the object, denoted by Fg, which equals the product of the mass of the object, denoted by m, and the acceleration due to gravity, denoted by g. In the formula, the unit of mass is the kilogram. The unit of acceleration due to gravity is meters per second squared. And the unit of weight and of gravitational force is the Newton. This ship has a mass of 2 tons or 2,000 kilograms. So its weight, or the gravitational force acting on it, is 19,600 newtons. Next, we know that an object immersed in a fluid is pushed up by an upward force called the buoyant force. Do you still remember how to calculate the buoyant force? Archimedes' principle states that the buoyant force acting on an object immersed in a fluid equals the mass of the fluid displaced by the object multiplied by the acceleration due to gravity. Together, both the gravitational force and the buoyant force acting on an object determine whether the object will float, sink, or stay still in the fluid. If the gravitational force is equal to the buoyant force, the object will stay still in the fluid. If the gravitational force is less than the buoyant force, the object will move upward to the surface of the fluid, or we say it floats. If the gravitational force is greater than the buoyant force, the object will move downward to the bottom of the fluid, or we say it sinks. So, if the weight of water displaced by the ship below the keel is equal to the ship's weight, then the buoyant force acting on the ship is equal to the gravitational force acting on the ship. And that's why this makes whatever is above the keel remain afloat above the waterline.